There we go. Advent of Code Day 4. Got 40 seconds out. As usual, got my command ready to set the template, download the input, and T minus 5. Here we go. Boom, there's an example. Okay, I see some fun parsing here. Okay, what are we looking for? Elf's pile is worth 13 points. Okay, point stuffing. I do have it manually ran, whoa, dude, at the beginning of every solve. As soon as it hits 0, I run it. Thanks for coming on by again. Hit by new line. Don't forget to trim first. Nope. Then map line. Let's see what we need to do. Has 5 winning numbers and then 8 numbers. For our winning card is worth that many points. Okay, what's up with the divisor? We'll figure that out in a moment. Line const id equals line dot split space 1 dot split colon back plus, and then what we're going to do is the const. What are these? Number groups equals line split by colon space and split by vertical bar map group dot trim dot split by space dot map number. There we go. Return ID number groups. That should be enough there. Now we filter out the winners and the losers. Looks like each card has 2 lists, a list of winning numbers and a list of numbers you have. Okay. The first match in each match after the first doubles the point value of that card. Interesting. 13, 61, 121. Wait, how does that work? 13 points, 2 plus 2 plus 1. How did that math go? Okay, the example card has 5 winning. Of the more math, more math. Ah, oh, I'm happy to hear that. Whoa, dude. Card 1. 1 for the first match, then doubled 3 times for each of the 3 matches after the first. What kind of sentence is that? Okay, let's just go through this, I suppose. Const winning numbers equals number groups 0. Const having numbers equals numbers group 1. That's not what I copied. Okay, now try to figure out this weird logic. How many winning numbers? Const numbers. Well, hold on. First. Winning numbers add, which is basically having numbers dot filter number winning numbers includes number, basically that right there. Const let score equals 0 if winning numbers had length score plus plus. Let's figure out this logic once more. Try to read it again. The first match makes your card worth 1 point. Each after the first doubles the point value of that card. Okay, so for let I equals 0, I less than, well, I equals 1. Come on. Keyboard's been a little annoying today. Numbers had length. I plus plus. It's a score plus, well, it's multiply equal to double. Then we have all of this, which I can, just spit it all out. Winning numbers, having numbers, winning numbers had, and score. So what? Return cards reduce A, B, A plus B, initialized to 0, but not B. B dot score is worth 13 points. Oh, because that first one's worth 8 points. I didn't do the math there. How many points in total? Okay. I'm a little bit slow on this one. Where is NPX? TS. There it is. Yeah. It's slower on the uptake on this one. I didn't copy. No, it did copy. That's not right. Make sure you're using the full input data. Blah, 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 blah. Great. So it's working, but wrong input. Okay, I guess this is mainly making sure my card parsing is working since there is nothing else happening here. Come on. Sorry, you're not fully cooperative. Okay, 216 cards. Let's just look at a couple of them. Look at all these IDs. That's okay. That's sad. That means parser is super unfortunately not working. After the first place, before the colon, great. Are number groups at least working? Where's my input? Look at that spacing. Okay, weird spacing. I'm splitting by spaces, which means this is not doing coolness. Figured it out. Okay. Can't split by single. Come on, close. Okay. Keyboard literally failing. Switch to backup keyboard. Gotta be prepared. Okay, so we're not splitting by spaces, we're splitting by we're splitting by white space, period. But this here, we are not splitting by this. Oh, sorry, all the keys are slightly off on this keyboard. There we go, that should be satisfactory. Number is changed. Boom, okay, there we go. Part 2, in this total, 30 whatevers. Is it the same case or no? We're about to find out. No example goes differently. I'll copy it just in case. Keep that do line for the trimming. Okay, what do we do in part 2? When more scratch cards. Wow. Okay, card 1 has 4 matching, so only 1 copy each of the next 4 cards. Cards 2, 3, 4, and 5. 1 copy each of 3 and 4. Your copy. Ooh, duplication. I like that. 4 matching. The next 4 cards. Got it. Oh, okay, I'm not going to read all that because I think I have the logic down. Hope that don't bite me in the butt. Okay, so what I need to do is I need to do all this parsing and then do the duplication. When copy of each of the 4 cards. So cost cards by IDs equals cards that reduce A B, turn A. Yep. Shut up, TypeScript. A b.id equals B. Great, that should do that trick. We have all our cards grouped by IDs. Now, for how many matching numbers you have, basically for that length, you duplicate ID. Well, for loop goes from I plus 1 to I thing. Got it. For cost card of cards by ID, no, of just cards general. Now, what do I do with all these duplicates? All the cards, you end up with one instance of one, two instance of whatever. Ultimately have 30 scratch cards. Hold up. Process all the original and copy it until no more are one. Uh-oh, I gotta read this more. You have 4 instances of card 3, have 2, so you want 4 copies of 4 and 5. Ooh, I can see the optimization needing to be done here already. How big's my input? Ah. Okay. We're gonna just see if we're gonna do wrong long running and suffice. Okay. For let I equals card ID. I less than card ID plus card winning numbers had length I plus plus. Oh, come on, get back in there. Cards dot push. Yeah, push it, then I'll have to do the sorting, right? How do I make sure I don't reprocess a single card? I can mark it as processed or remove it from the list. I'll remove it from the list. Or I'll just physically mark it processed. Processed false. There we go. Cards dot push. Cards I. After you're doing all this, A B. No, hold on. Until I am out of scratch cards. I just keep on adding until no more changes can be made. So while true. Nope. Come on, keyboard. Don't go down that. Nope. Sorry, that key is different on this keyboard. Total equals cards dot length. There we go. If cards dot length not equal total, or if it is total, basically there were no changes. Darn it, wrong key. Break. Then what am I doing? Turning cards dot length. That feels right. I'm not using that process trick. When that cards cards by ID. There we go. Okay, let's see if I have an infinite loop this. It appears I have infinite loop lists. We love that. Let's try and jump in here directly. Okay, let's see how many. Oh, next line, please. That's not the F5, that's F6. So, F6 cards. Okay, we just hit an infinite loop because this right here is happening. How many cards do we have at this point? Be good to me, JavaScript. Awesome. Billions. Cards. Slice. If card processed. Continue. Just ignore that. We're gonna say card process equals true. But we have to make sure to make copies of this object here. Notice that same process reference is going to be modified on all of them. Let's see if that does any better. Ooh, okay. Good, just wrong now. Okay, let's see what we actually ended up with. We ended up with 32 cards. So, 1, 2. Okay, let's actually do some kind of sort on this, or count at minimum. A, B, beta ID minus B dot ID. Why are you angry? Oh, that's wrong symbol. There we go. Okay, so we got two twos. I have 3 ones. How did that happen? That should not have been possible. This loop must be broken. Back into the equation we go. Yep, so we're on card ID of 1. We're looking at an I of 1. Well, that's the problem. Okay, let's see if that got me close. Terminal, please. 14. Okay, probably a 1 off on the other side, I feel like. It's 2, 3, 4, 2, 3, 4, and 5. There we go. See if terminal made it. 24. We're getting closer. I'll have to check the whole count again. I feel like that is working. Let's zoom, resort, and have ourselves a lucky look. 24 cards. So 1, 2, 2. You have 4 instances of 3. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7 instances of 4. Nope. I did not get 8. I only got 7. So I have 4 instances of card 3. 1, 2, 3, 4. Correct. These are all processed. Yes, they are. Okay. Have 2 matching number. So 4 copies of 4 and 5. 2, 3, 4, 5, 6, 7. 9 of 5. Yeah, so yeah, we're losing 1 somewhere. Maybe this isn't working. Let's jump back into here. Particularly, I need to get to, what is it, card 3. So let's zoom ahead a little bit. Oh, that was very quick. Yeah, that's right, because I process them one by one, and then I refine them again. Original cards being processed. Making sure this, because this card reference is what I'm being. I'm actually resorting this every time it hits. Might be easier. Get back in the debug, please. This one is a stumper. Because I know I'm off just by 1. Yep, so as soon as you push, resort, make my life easier. After you process, let's go look at that too. Let's actually look at our cards. Yep, so you got 2, 3, 3, 4. 2, 3, 3. Hold on. Card 1 is 4 matches. 2, 3, 4, and 5. 2, 3, 4, and 5. Okay, man, thanks for this code. You really highlighted that weirdly. Come on, go forward. I should also put the brake on here. It'll be fine. So for 2, we now have 2, 3. Yeah, this is fine. I just need to get to card 3. Okay. Just copy 2. You have 4 instances of card 3. 1, 2, 3. That is a lie. Let's get to the end. Okay, get to the end, I say. I eventually get 4 instances of card 3, but not in the order that it appeared in. That's annoying. There we go. I just need somewhere to put my breakpoint. What am I missing? It's definitely this duplication one, right? It's nothing else. Yeah, card 1 has 4 matching numbers. Okay, good. On to the next one. Card 2 has 2 matching numbers, so you win 1 copy each of 3 and 4. Your copy also wins 1 copy of 3 and 4. Then I get to 3. Yeah, 1 gives me a 3, 2 gives me a 3, 2 gives me a 3. I should have 4 3s. If it's failing, somewhere around there it's failing. Gotta go even more granular. Okay, show me the cards. Okay. I think that's the one we care about. There we go. We care about that one too. Okay, now 2 is gonna give me 2 copies of 3. So the first 2 is gonna give me a bunch of 3s. Next, one of these, both of these are unprocessed, so go on. Yep, we got a new 3, 4, 5. We got a new 3, 4, right? Then we're going to process this. Now we're on to 3. Process 2, process 2. Nope. The processing order is wrong. I don't think it's having an impact, but it's messing up my simulation. Because I'm slicing this. If I don't slice it, it hits the infinite, but I have the processing logic, so it won't hit infinite. Yeah, I think we're okay there, but I'm sorting it. Let's do a for of loop, or an I loop. For let c equals 0, c keyboard. C less than cards.length, c plus plus, a const cards, c, drop that, save it. It should make it easier for me to follow through at least. Check terminal. Well, of course not. Hold on. If terminal's not running, that means I hit infinite. I hit infinite. I do that. Hold on, break off. Cards 14, 16, we're on 3. We're on 3. Maybe we have 4 threes, now we're on 4. Okay, let's just break off and go. Cards length 30. That is correct. Oh, I am doing long execution right now. That's what's happening. Okay, rerun it. Don't watch. We have a solution. It's a bad one, though. Okay, let's try and look for better math in that case. Because there is a math solution to it at this point. It's a bit of a dependency chain logic here, too. So if I solve it in reverse order, no. How bad is this? It's taking a moment. The thing is, there are 14 instances of card 5. We don't want to keep doing this because we do it too much. That's why it's taking half a millennia to run. So we need to think of a different approach. Hmm. It's numbers that we're doing. It's one of those things where, hey, if you know what it's called, you know what it's called, you know how to implement it. But if you don't know what the particular pattern is, it's hard to recognize. Hmm. Let's keep that open. Math. My greatest nemesis. Hmm. Don't I just need to count how many of each card there is? I don't need to actually create new cards. So that's going to save us a lot of memory. Counts equals, well, it's going to be IDs, basically this, but numbers. ID equals 1, congratulations. Instead of adding all the new cards, I would add to the counts in a way that is cool. Did that finish? Nah, I'm trying to be like, can I just not? But no. Yes, I mean, this is running not in watch mode. If it wins, it wins. Otherwise, we'll figure this out. So what I gotta do is do it mathematically, not object-orientedly. Okay, so every count starts at 1. We got that. Total is here. We do have to go through each card. And it's from the card ID to how many have matched, which we have that. We just add to the counts of those cards. Counts I plus equal 1 No, it's one wouldn't work. It has to be multiplicative. So we have 4 instances of card 3. It's how many I have for myself. Because 4 of 3 becomes 8 of 4. Actually, no, it's easier to just try and see if it outputs the correct thing. I don't think we need that sorting. I mean, we do need it for the old stuff, but we're not doing old stuff. Did it run? It didn't run. Ah, where's F5? Found it. Okay, what counts do we have? Something might be... Well, there's 30. Actually, hold on. That's actually what I kind of wanted. But it's in that slot. Okay, let's shut this up. I can do some manual poking around. Well, that's probably what's hurting it right there. It's my duplication. I need to process each one once, not in multiple. Okay, let's try that again, actually. Yeah, I think. Okay, how's counts look now? Now can I just sum all these together? Debug console. Count. So 1 plus 2 plus 4 plus 8 plus 14 plus 1 is 30. Okay, that's it. That's what we do. We don't do the rest of this. Yeah, okay, good. So return object.values counts use a b. Come on, mouse. Plus b starting at 0. Get rid of that line. Stop. Stop. Why angry? Why angry? Oh. No, not check, ignore the other one. Okay, so we're going to keep that terminal for us running. Just spin up a new one. Ah, great. What day are we on? Nope. Okay, big number. Looks like. Hey, okay. Just took a moment for me to figure out the math and get a little lucky there. Yeah, not too bad. Yeah, like I kind of figured out, it's one of those things where first I had to get it working right, which was hard enough, and then realized that yeah, that was going to be inefficient and had no chance of actually passing. So had I bailed on this a little sooner, I would have gotten there. But then I wouldn't have been confident in what actually needs to be done. But yeah, all in hindsight, should have just went for the math way as soon as I realized how not exponential, logarithmic, or bad math the way this was gonna go. But we got it, so that is good. Yeah, not the worst performances. With that, I will commit it as is. Let's see. That's bad math is still running over there. Yeah, that's a fix up I had. Do. Boop. Bada. Day 4 solution. Now let's clear up a couple TS ignores before we throw that in there. Does that go? Boom, boom. Leveling of that. Any others we need to throw? No, that was the only TS ignore we needed to handle. Butte. T full. Re-add, commit. And there we go. With that, we will be taking our break, coming back, optimizing, and going through it a little bit more. I'll try my best to break down the efficient mathematical solution a little slower. With that, see you after the break. Welcome, welcome, welcome on back. Let me shift back on over here as we optimize day four's solution. First, by trying it out. Primarily with the parsing, because a lot of the parsing is identical and getting rid of stuff that we didn't end up using. Yeah, so when it comes to the parsing, we cared about the score and that one. And here we cared about how many winning numbers the the card had. And the score is derived from how many winning numbers it had. So everything else doesn't matter. Right? So it's this, it's score, and score can be calculated from that. So cost numbers to score equals number. And there is math to this. Just not going to do it right now. I'm doing this here because this is only needed for part one. So we just need to know how many winning numbers there were. Numbers 1. I like that better. The verbiage of it. Okay, now the rest of this, let's just trim this down very much. Yeah, I can split this right here. Winning numbers. Add numbers. Add numbers. Let's look at this. That's what they call these actually. Numbers you have. Numbers had. Numbers had. And then this can straight be a... Oh, that's past tense, not present tense. This can be this dot reduce a plus b start at 0, but it's going to be if winning numbers includes b, they were like a boolean. Bam. No more dot length. Beautiful. Now the rest of this is dependent on what actually is being asked. So let's move some things around and put some things into functions. Probably don't even need that. There we go. Trim map gives me ID, gives me the numbers of numbers 1. Whatever. Cards here, data, and then we can probably go straight to the reduce. I'm just gonna steal this. Yoink. Yoink. And while we don't have the score, we have a method that can calculate it. Right here. Boom. So that's part 1. Should be working beautifully. Now part 2, a little more complicated because it's the math. Yeah, we're not doing process logic anymore. Never needed that. Just one. Let's first make sure made a significant number of changes. This still works. Should be able to run in watch mode. Let's see if the big calculation still hasn't ran. Love that. It is 55. Yes, it is. Okay. Not broken. We love to see it. See, I'm happy with part one. I am satisfied with this. Split. Let's make this a little more readable. Map, then for each one, do that. Good enough. Yeah, Regex could magic this, but I'm satisfied as is. Now we have this bit. I don't believe I need direct loop control, so let's... Where's that home key? I also don't think I'm going to need this while loop, but let's not get too ahead of myself. Boom, runs beautifully. Let's drop the while. Runs beautifully. So yeah, this is the crazy math. And then it just sums them all together. I'm just looking at this, trying to see numbers. It's not working. Okay, at this point, we can at least go with the straightforward explanation of part one. I got that one fully understood. I say as I go back to read the description again. So yeah, both of them, no matter what we're doing, we need to parse these cards. So we need to extract the ID of the card, the numbers after the pipe that are also before the pipe, because before the pipe represents the numbers that mean you won. The ones after are what you actually got. So in the example, we got 48 is a number that we got. That is also a winning number. So we got one. And it's basically how many you got goes into the score calculator, which probably could optimize. Because it's one for the first point and then double for the rest. So this is score equals winning numbers, double flip urinary. And that's just duplicate it that many times, which, if memory serves me right, yeah, that thing's never gonna run. This is a powers thing, right? 1 power of 2, power of 3. Nope, it's not the powers. Yeah, I think it is powers then. Right, so let's look at their example. So if you win 2, then it's worth 2. Nope. Okay. I'm thinking this is definitely a mathematical pattern. Just not seeing it off the top of my head. I suppose that's okay. It's not the most complicated thing here. But yeah, the way we're doing the parsing, we can't split by just a space because when we get to real input, things are nice and formatted for us. They were so kind. Which means splitting by a single space breaks this into, gives us this 0 character string right here. Not what we want. So we say, hey, split by any number of white space you can find. So it's just a white space separator. Get as many as you can. So we do that both for grabbing the ID and for the individual digits. And map to the number of JavaScript. Nice little trick there. It's a constructor, but also a function. Then we just count how many are 1. Now this can be optimized by throwing it into a set. It's a worthy optimization. There we go. Makes those lookups a lot more performant. O of 1 instead of O of n, which isn't that bad considering n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's the thing. For each of those 10, it's this many times executed. So that's where it does actually help. So we love that. Let's kill that terminal. Yep, still working. Then what we do is based on 1 or 2. For 1, we want to convert how many numbers we want to the score. So we just convert it and sum those up accordingly. And for part 2, our goal is to get the number of scratch cards that we have while matching a number duplicates one scratch card in front of you. So card 1 matching 4 numbers duplicates the 4 scratch cards in front of it. And I believe the trick here to the math is that we're adding to it how many times we exist. So 2 is getting added to it once. It'd actually probably be easier to just walk through this instead of me just trying to remember and do math in my head. Right, so there's counts. So 1 of each. We're at card 1, which means 4 have been won. Means we are saying, hey, card 2. Actually, come on, let's do my... Might need to format some things around here. Trying to figure out which ones I want to show. Okay, let's do that one. I need to open that up too. There we go. So current count of that is that. Card ID is that. I is this. I'll put that one over there. Okay, it should be enough to follow. We just have counts over here. We have to look at it with our eyes. There we go. So this is going to be adding 1 to 2. Now we're moving on to 3, adding 1 to 3. Moving on to 4, adding 1 to 4. And adding 1 to 5. Okay, and the next one we go through, this is card 2. Now there are 2 of these card 2s being ran. So instead of doing what I did before and running through this addition twice, we do it once. So we're going to be adding to 3 the effect of card 2 duplicating it twice, which is going to send it straight to 4, I believe. Yeah, because current count is that, and let's actually show what current is. Boom, yeah, so 2 plus 2, 4. The same thing for card 4, I believe. And I don't think we go any further. Yeah, then we go to 3, which, as mentioned here, we have 4 instances of it. Yep, so whatever this is going to do, does it 4 times to all of the next cards. So it'll be plus 4 to 4 and plus 4 to 5. Let's watch that happen. Should go to 8 and then 6. Beautiful. Now we're going to move on to card 4. Which we have 8 of them. It's going to get 8 to 16, which is going to push us to 14. There it is. And that's it. And then 5 makes no changes to any following cards, and 6 is the last card. Okay, so I guess, yeah, they designed the game generation good enough that the last card is never a winner. Because if it was, it'd go out of bounds. Lucky for us, it is not. So yeah, hopefully that made a little bit of sense how that math worked. You just had to slow down and, because I was following it through logically as a human would, but I'll let the computer do its job. Let's see if I can, make some moves here. Go, just shortening since why not? What have I done? Computer property. But what is? Oh, B dot. What are you? ID. There we go. Fixed it. Satisfactory. Now, since this is such a simple loop, I'm gonna do the forbidden thing. Get rid of all the extras. Okay, with this, I am okay. I'm not happy with it, because I didn't really. I just, you know, kind of got lucky by figuring it out manually, then getting to it. And I'll tell you what's so the dissatisfying part is that there's nothing I really could have done to improve my performance this time, aside from the keyboard not freaking out, because I just didn't know what I didn't know. Like, with hindsight being 2020, would have done the exact same thing. Maybe shifted the more performant one first, but I need to understand the process before going for performance. So yeah, I think this is as optimal as this gets. I haven't even put a single thought into visualizations. Do and yep, that's good with me. Time to push away. Lovely. Yeah, so I mean, what part one visualization would look like? Straight up terminal visualization, I'd say. Show a card, highlight the ones in green that are matches over there. Have a little thing over here that shows the score count. Since it's literally a sum of the score, what the heck? Or points. Just have it kind of like that visualization, a horizontal line down here, and then boom, that's your part one. Pretty straightforward there. I could, if I really wanted to get into it, show the searching of this, highlight this in yellow, highlight this in yellow, yellow, yellow. Boom, I found them both. Green. This in yellow. No, this in yellow. All 5 of these in yellow. Boom, turns red, or it turns gray, or does something. I could do that. So yeah, that's definitely part one visualization. Part two, however, aside from about the most boring bar chart you've ever seen, that's literally just going to represent physically counts. I'm not seeing anything interesting there. Okay, let me actually jump in and debug, see how big counts get. Because that's always the thing of like, oh, sure, I can visualize something, but does it scale to 5 billion? Or whatever the number's raised to. Hit the wrong F key again. Again. My keyboard's Bluetooth or 2.6 gigahertz, whatever it is, on the fritz. So I've had this backup one plugged in old good old PS2. Ah, yeah, you see the counts go into. Oh, that's interesting actually. They cycle a bit here. Yeah, we got 12,000, 12,000, 32,000. Well, at least they're staying below 100. I open my mouth. 300,000. At least they're staying under a million. Okay, appears they at least stay under a million. So, what my idea was going to be, which is completely gone now, is to have, I guess, a grid of cards, just like where cards would live, and be like, oh, look, it's a little card. And then how many versions of those cards were, they would, look like a stack. So I'd just be like, oh, look, it's another card. But, same shape, but rotated scale just slightly a little bit. And just do that for how many cards that pile has. But, 698,000. Don't believe the browser would care too much, no matter how I decide to visualize that. Doing anything 600 and something thousand times. So that's a no. Yeah, I don't see part two really getting visualized here in any interesting way that I can think of. Which ironically means that visualization for part two would be the most valuable, being how mathy and conceptual it is. Hmm. It's almost following powers. I think that's just coincidence with the input data. Hmm. Yep, that's all I can think of there. Back to the more reasonable part one. Yeah, that's one that's definitely going to be getting a visualization, just because the simplicity of it is relatively straightforward to visualize. It's something that can be actually followed along. Unlike part two there. But tomorrow is Monday, so can't spend but like 5 hours here actually visualizing it. So I will say adieu. Appreciate y'all coming by, following along. Hopefully it's helped a little bit. Let's get rid of all this go expressions. There we go. Yeah. Be back here same time tomorrow for day 5, which should be, if anything is to say about the days of these, lowering out a little bit considering, it's weekdays, not weekends, but we will see. Difficulty's been fluctuating a little bit, but I have been loving it. So, we'll catch you tomorrow. Bye bye, world.